Good morning, friends. Today we are going to discuss the next chapter of the Unit 1 of the Physics 1, Paper 1, Elasticity. As you are aware about this particular fact, you studied already in the 12th, that is the elasticity. When we have to study this particular property, elasticity, when we talk about elasticity, simple example, the rubber, when you stretch, it is elongated. When you compress, then it is when you apply the force in the forward direction or say upward direction, then it will get stretched, whereas if you apply the force in the downward direction or say in the backward position, it will get compressed like this. Just this is the example. Here you can see that when any force act on a body, it undergoes the certain deformation. If a body completely recovers its shape when the deforming forces are removed, then the body is said to be perfectly elastic. The MCQ will be there on the perfectly elastic body. Steel is highly elastic. It returns to its original shape even after being subjected to the large force. However, most of the bodies are perfectly elastic within the limited range of the forces. In regaining the original shape, there is an internal elastic force. The net internal elastic force acting per unit area of the surface over which the deforming force is applied is called as the stress. This is the MCQ based on the stress will be there. The net internal elastic force acting per unit area. Okay, force acting per unit surface unit area of the surface over which the deforming force is applied is called as dot dot dot. The units of the stress are those of the pressure, that is a Newton per meter square in MKS system and dynes per centimeter square in the CGS system. That may come for the MCQ. Then dimensions are M1, L minus 1, T minus 2. In the 12th year studied how the dimensions are written. Then stress brings about change in the shape or size of the body. The change in the dimension per unit original dimension is called as the strain. The MCQ will be there. The change in dimension per unit original dimension is called dot dot dot. Okay, it is a ratio of the two quantities having the same dimension. Strain has no dimensions and units. Elastic limit is the maximum value of the stress up to which Hooke's law hold good. And Hooke's law said that within the elastic limit, the stress is directly proportional to the strain. And this constant ratio is called as the modulus of elasticity and is a measure of the elastic property of the body that may come for this particular MCQ. Hooke's law says that within the elastic limit, stress is dot 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 proportional to the strain, directly, inversely, equal to, okay, like that. Okay, then this constant is called as the modulus of elasticity and it is a measure of the elastic property of the body. The MCQ will be there based on this particular thing. There are the three different types of the modulus of elasticity. One is the Young's modulus, bulk modulus, and the modulus of rigidity, Y, K, and eta. Then the Young's modulus is nothing but a ratio of longitudinal stress to the longitudinal strain that may come for the MCQ. Here you can see longitudinal stress divided by longitudinal strain. Stress is nothing but that is a force acting per unit area, that is F by A, it is a stress, and the strain is nothing but a change in that we have seen. Strain is nothing but the change in dimension per unit original dimension. If length is there, longitudinal is nothing but a length. That's why small l is the change in length divided by original length, LL. If you multiply, if you take these values F by F, A and L by L, then you will get a FL divided by L, where F is the stretching force acting normally over a section of the area L, and L is the original length, and L is the change in the length due to the stretching force. Then the bulk modulus or say volume modulus, K, is the ratio of the volume stress to the volume strain. Volume stress to the volume strain. The stress is simply the pressure increment delta P which cause the volume strength. Delta P by delta V upon V. Therefore, V into delta P divided by delta V, which is equal to K, which is equal to constant for the given material, and is bulk modulus. The compressibility is defined as the reciprocal of the bulk modulus. Reciprocal of the bulk modulus is called as the compressibility. It is denoted by the symbol B. As the fluids can permanently withstand or sustain only hydrostatic pressure, the only elasticity they possess in bulk modulus. There are two types of the bulk moduli result, that is isothermal and adiabatic. That depends upon these two things, temperature and the heat. Then modulus of the rigidity, that is eta, it is nothing but a ratio of the shear strain, that is a shear stress to the shear strain. What is the shear? That you may see that we get the shadow when any body we are keeping, at that time you see that the slight body is looking, their shadow is looking, that is a shear. When a solid body is subjected to the transitional stress and it undergoes a stretching strain, then the ratio of the transitional stress to the corresponding shear strain is called as the modulus of rigidity. Okay, eta is equal to F by A divided by theta, F divided by A into theta. The SI unit of the moduli of elasticity is Newton per meter square, and the dimension is the m raised to 1, L raised to minus 1, T raised to minus 2. That you have to remember. Okay, this is the common one. Because whatever the dimension and the unit is there due to the stress only. Okay, then next part is the Poisson's ratio. Poisson's ratio is nothing but the ratio of the lateral contraction per unit breadth to the longitudinal elongation per unit length is called as the Poisson's ratio. It is denoted by the sigma. Poisson's ratio is the ratio of the lateral strain to the longitudinal strain within the elastic limit. Here that diagram is considered. Here you can see lateral strain to the longitudinal strain. Okay, length and the longitudinal and the lateral. Okay, length is changing and there again there lateral modification is there. Here you can see the derivation is also given to you. Here sigma is equal to lateral strain divided by longitudinal strain, which is equal to d delta dd up by d. Okay, lateral, that is a diameter is there, longitudinal is nothing but length is there. Okay, it has no units and it is a dimensionless quantity. Okay, Poisson's ratio is the dimensionless quantity. There will be the MCQ based on this part. Please go through this part well. If you are not getting, you can ask. Okay, please prepare it well. If you are not getting, you can ask me. Here we will stop. Thank you.